Hello student, welcome to Chatterjee Academy. So today's session is for the students of the CBSE and ICSE board who are appearing, and also for the JEE next level in the month of April. Okay, so this session will be helpful to get you some the basic concept on the self inductance. So from today we are starting the small session which will purely focus on your basic, because lots of questions, lots of material you have, but yes, also basic is always required. Without getting ready for basics, it will really be challenge for you, to integrate everything in your mind, right? So basics should always be with you. So we have choose the self inductance today, right? Because this self inductance is very confusing sometimes. After getting ready, after few days you are forgetting. So just I want to make it easy so that it will be with you. Okay, so let me go to my screen. Okay, so I have few part ready for you. I hope you can able to see. Yes. So self inductance. What is self inductance? Self inductance is basically the it's caused the oppose in the electricity, right? So we choose a coil and we'll flow current over there, and we'll see that the self inductance, that is presenting an inductive reactance, and this inductive reactance is opposing the flow of current, change in current in the circuit, right? So self inductance is very important because we have multiple chapters in electricity. First is the what is self inductance. This is one chapter. Then you have to understand what is mutual inductance. Next is that in the alternating current chapter you have to understand what is inductive reactance. It's a kind of the inertia, electrical inertia, oppose and what are the laws that involve the Faraday's law and the Lenz's law, right? So self inductance is very important. Once you understand self inductance, you will understand the the different set of inductors, like if they are in parallel, if they are in series, what will be the net inductance. The next is that that what is mutual inductance, like transformer. The principle of transformer is based on the the principle of this inductance, right? So there we'll get the mutual inductance concept, how one inductance is one coil is impacting the other coil with respect to the change in magnetic flux, right? So those are basic things, and so that starting point is the self inductance. Okay, let's come to the point. So we took an coil here. So this is a solenoid, right? Inside this coil we are sending current. We are sending current in this coil. So what is happening? Once current is flowing in the coil, it will produce magnetic field. It is part of the electromagnetism. Now, it's producing magnetic field. That means we will get the flux. So flux, what is flux? Flux, what is most fundamental? The field. The flux is coming from the field, right? Phi is equal to B across theta. Okay. Now, when we are changing the current in the coil, let's say the current getting changed in the coil, okay, for some reasons, so it will produce the magnetic field, and this magnetic field nature will be changed because the amount of current is getting changed. So the magnetic field is related to the amount of current. Similarly, for this magnetic flux will be changed. So there will be a change in magnetic flux inside this coil. So that's why I have drawn a flow chart for you. So this way it will help you to understand, and you just do a practice in a white page. Take a page and practice like this. Just write the keywords and try to connect with your mind. This is very important because this is very common that we are studying it multiple time and again we are forgetting. Then how to pack up, how to get it ready for my exam, and how to say, okay, I am ready with self inductance. I don't have to look on it. The conceptual part I am ready. It will save my 10 minutes at the time of preparation, right? So just go through the flowchart and just you write down the flowchart. It will take 1 minute for you, and it will also help you to practice. You don't have to go to the back to the books multiple times. So first is that current through coil varies with respect to time. So as I told you, inside the coil we are varying the current, right? So In the flowchart, first line is current through the coil varies with respect to time. So you can say it like a chronology report. Okay. So change in current cause change in magnetic flux. Change in current cause change in magnetic flux. So now change in magnetic flux. Now here Faraday's came. Faraday's law of electromagnetic induction is telling that change in magnetic flux will produce induced EMF. Where it will produce in this coil. Here we will get the induced EMF. Now induced EMF caused induced current, right? So induced current will be coming. Now this induced current, then Lenz's law come. Lenz's law told that that this current will, the new induced current will oppose the change in magnetic flux. So change in magnetic flux means it will oppose the change in the current, because full show we started with change in the current. Change in current cause change in magnetic flux, that cause induced EMF, that cause induced current in this existing coil. Okay. Now this change in current, the new current, it will oppose the change in the flux. That means it will actually opposing the change in current, right? So Lenz's law and Faraday's law is coming here. What is the net result? The net result is that in this coil, whenever currents are getting changed, it gets an oppositions, it gets an inertia. So that's the back EMF. Back EMF. That's called back EMF. And next is the inductive reactance, XL, right? The symbol is XL, right? Inductive reactance, XL. So whenever you are going to study the alternating current, we will know that XL is equal to omega into L. So now L. Now how we are going to quantify L? What is L? L is the symbol of the self-inductance, right? Now let's see here the derivation part. Let me zoom it out for you. Okay. Okay, so let's focus here. If you see here, so we know that in the solenoid, the magnetic field B is mu 0 Ni. So N is the number of coil, I is the amount of current, and L is the length of the coil, right? So magnetic field, the magnetic flux is phi is equal to BA, means B into A, right? The flux we receive. Now Faraday's law of electromagnetic induction, induced EMF is equal to minus N d phi dt. N is the number of coil and d phi dt means rate of change of magnetic flux. So we receive that epsilon is equal to, yeah, let us zoom it out. Epsilon is equal to EMF is equal to minus L di dt. So now this L means this part, right? N and the mu 0 N IA. This is the L, right? So this is called this is the value of the self inductance. Okay. So self inductance is equal to mu 0 N square A L. A is the area, L is the the length of the coil, and the N is the number of coil. So self inductance, the electrical inertia depends on these factors: the area, the length of the coil, and the number of coils. Okay. Now, so this is the measurement, and this is very important to understand because 3-4 chapters are related with this part, right? I hope this session will help you, and the focus of this session was not to run a regular lecture, just to how to revise, how to keep the thing in mind. That is the most part of crisis, right? If you and this is the backbone, this is the building blocks. If you cannot ignore it, just go through it and practice it, and I believe that it will help you to help to solve the problem of JEE and JEE Advanced. Whenever we are helping you, whenever you are taking different session in the complex problem, right? So this is the building block. If your building block is ready in your hand, so it will really help you in the coming board for ISC, for CBSC, and also for the next attempt of JEE. Okay. Thanks for watching the session. Okay. Keep follow my session. I will just give you few more session with this flow chart level, and this flow chart is very important. You can go and practice like a flow chart. Okay. Thanks for watching. And if you like my videos, please subscribe Chatterjee Academy channel, and so you'll get the regular update on the free session. Okay. Thank you.